Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we're going to talk again about constant acceleration problems. We, in the last video, learned about the three major equations to solve problems. So here are the three big guys, and we are going to do constant acceleration problems. So we're going to do a couple problems, so I encourage you to copy down these examples. Now, when you're doing the physics problems, they're typically going to be like a word problem, and then you have to figure out which of the three equations you're going to use based on what you know. So it's really good to start with a table. Everybody start with a table. Table. Make a table. Make a table like this, where you're going to say x initial, x final equals v initial, v final, a. Now, a is not going to have an initial final. It's just going to be a because we're in constant acceleration. So this is always the same number and time. So let's say, for the sake of argument, that we start at rest where x is 0. And its final speed or distance, it goes 50 meters, right? It starts at an initial velocity of 0 meters per second. So it's starting at rest at 0 meters, right? And the question is, we want to solve for, let's say we know that the acceleration is 3.5 meters per second squared, and we know the time is 9 seconds. The question is, what's the final speed? So we know all of our numbers except for v final. So now which equation are we going to use, 1, 2, or 3? It turns out we want to use number 1 in this case, I think, right? So I'm going to say x final is 50. So I'm just going to recopy the equation. I'm going to substitute in the numbers. 50 equals an x 0, right? Plus vi at 0 times 9, of course that's 0, plus 1/2 times 3.5 times 9 squared. And the goal is to find the final, what do I want to find? The final velocity. All right, so I've chosen the wrong equation because I want to find the final velocity. So I want to use equation 2 here, don't I? Totally want to use equation 2. So ignore that moment because it's like, wait, that's not going to work out. Now let's try that one more time. So we're going to use equation 2. I want to find the final velocity. So equation 2 is v final equals v initial. What's the initial v? 0 times plus itself plus a, which is 3.5 times 9. So 3.5 times 9, get the calculator out. 3.5 times 9, I way over. I have an error on my calculator. 3.5 times 9, there we go. I get v final to be 31.5. That'll be in meters per second. Okay, watch that. So I picked the wrong equation on the first attempt. That was my error. So let's change the numbers here. So you go ahead and make a new table in your notes. Let's do another type problem. And let's do one where we have, let's say, we're going to again start with this to be 0. X initial is going to be, or final, pardon me, is going to be 28. We're going to start at rest at 0. And again, we're solving for this. And we want to solve for this as, let's say this is 4. So now we don't know the final, we do know the initial, and we're trying to solve for the final. So in this one, we're actually going to want to use equation 3. Actually, let me talk about this for a moment. Do you realize the purpose of equation 2 or equation 3 is equation 2 does not have an x. There's no x here. And for this one, there's no t, no time. So if you don't have time, you have to use this equation. If you don't have x, you have to use this equation. In the last question, we knew time, and so but here we don't know time, so we don't know what that is. We could find it eventually, but so we have to use equation 3 in this case, right? And so we're going to say the final x, that's the x, if you will. So it's v final squared. Sometimes, by the way, and I'm doing this in my head, sometimes I just call this v1 and this v2. The initial is the first instance, and this is V2. So V2 squared equals Vx. The initial is 0. Well, that's super easy. 0 squared plus 2 times 4. Now, this says delta x. Let's talk about the delta x. Delta means the change in the x. And so this started at 0 and went to 28, so the difference is 28. But if you started at 5 and went to 28, it'd be 23 or whatever, right? So that'd be just times 28. And then we take basically this times this times this. What does that come out to? I don't know. Let's get a calculator. But you do see this is squared, so there's going to be a square root ball game in this. So 2 times 4 times 28 gives me 224 equals V2 squared. So you take the square root of both sides, and you take the square root of that answer, I get 14.96, and with significant digits, we're going to say that's 15 meters per second. So essentially the idea is that you've got these three equations. You're going to make table guy, and once you make table guy, you can solve the problem. That really is the gist of this as you solve these problems. Houston, you don't have a problem.